Now, let's talk about how to construct a hierarchy of singletons. That is, we have a base class that is a singleton, and its subclass should also be a singleton. How do we do that? What could be a possible application? We could have a system where there is a general purpose server that is a singleton, and you could have multiple subclasses of it that themselves are singletons. So for example, a file server that serves files, a directory server that looks up directories, and a special type of file server that only deals with files that cannot be modified. So it's a read-only kind of thing. So we could have those kinds of situations. So let's attempt this construction through a series of pieces of code. So this is our original singleton class B. So you can see that I have the private constructor and the instance method. Now, here is our first shot at creating a subclass that itself is a singleton. So we try to mimic everything that is here into here. So we have public class D extends B. So D says, our idea is that D will be a singleton class. And we copy this and change B to a D. We have a private constructor here. We have a static instance method, just like here. If singleton is equal to null, then it creates a new D and returns it here. So that is the code, but this just doesn't work, because when you try to create a new D, this will be invoked. This constructor D here will be invoked, and it will try to invoke the superclasses constructor, but that is private, and this constructor call fails, and then this whole thing just doesn't even compile. So this won't work. So you can't have this private, but so you can't really instantiate a D. So forget this. Well, then the next thing is, we can't really make the constructor of B public. So let's try to make it protected. Okay, let's keep it protected. Then if you have this protected, then this will definitely go through. No problem. The private D will invoke the constructor of B. Everything seems to be fine, except one little hitch. D can instantiate an instance of B. So here I could have a method that says new B, this superclass. So I can instantiate an instance of the superclass. So you could have multiple instances of the superclass B. So that also doesn't work. So what we try to do is go one step further, and in the protected constructor of the superclass, we check if somebody is trying to create a B object. So here now object is being created. We check what its type is. Remember runtime type identification? This is called a reflection. We get the class object corresponding to the object that is being created, get the name of the class, and check if it is equal to B. If it is a B, then this throws an exception. That is the idea. So that this object will not be created if it is a B, but then you can't even do this. You can't even create an instance of B. So again, we have a problem. So what we do is the following. Public class B, private static B singleton, same as before. We have two constructors now. One protected B, the other one is private B with a parameter. This parameter is kind of a dummy parameter. It is there only to distinguish this constructor from the other. You can't have two constructors with the same signature. So we are just adding an artificial parameter which is of no real use, except distinguishing between the two constructors that this class has. So protected B throws exception if get class dot get name equals B, throw new exception. So you can never instantiate an instance of B using this constructor. So this constructor is useless for creating an instance of B, but there is no such restriction here. So when B dot instance is called, I check if singleton is equal to null. If so, I'm creating an instance of B through this constructor and return that. Whereas if I am coming from the subclass, I check, is the subclass trying to create an instance of B? If so, I'm not going to allow it. Otherwise, I will let that go through.